File insecurity and encryption. Digital and manual files are similar in that they both store and file documents and/or information. The major differences between them are format. Digital files consist of information that is typed, while manual files are handwritten. Storage. Manual files are always in hard copy form, files or papers, in different places, while digital files are stored in soft copy in a digital location, computers, hard disk, etc. Transfer. Transporting manual files from one place to another is difficult because they would need to be carried everywhere. Digital files can be easily transferred through email and through many other forms electronically. It is also more time-consuming to transfer files manually than through a computer. The major benefits of using digital files are their time-saving in editing, changing, and transferring files. There's better efficiency in record keeping. It's easier to set up paper trails when needed for businesses, etc. Use of templates removes repetition in file keeping. No more paper and filing costs, as well as saving space, as less filing cabinets are needed for storage. Files can be accessed quickly and at any time. Using digital files does not come without its risks, and they do have limitations. For example, if the internet is down, you can no longer share a document with a colleague as you would by simply handing them a piece of paper. New users to technology can be skeptical about the authenticity and validity of digital documents, and therefore defer from using them. Security breaches are also a concern when it comes to digital files. File insecurity is the concept that all files have vulnerabilities and can be lost or missing in the computer. File security is a feature of your file system that controls who can access which files and can limit what users can do to various files in your computer. Some of the major effects of insecurity in files are losing, overwriting, or corrupting information. When a file is insecure and can be accessed by anyone, information in the file can be deleted or changed without the owner of the file knowing. Also, a non-authorized user can corrupt the file so that the next time the owner of the file goes to open it, it can fail to open and create problems for the computer. There are a few steps to take to ensure files are safe and readily accessible whenever needed. Keep your computer and devices updated, use strong passwords, use antivirus software, encrypt your hard drive and mobile device, and restrict access to others accessing files, non-editing permissions, etc. When practicing and developing means of protecting digital information, there are 5 pillars that are fundamental to ensuring the safety of a cyberspace. Confidentiality assures that information is not disclosed to the wrong individuals by ensuring that data is properly encrypted. Integrity describes a cyberspace's ability to ensure that information is not damaged or modified during the transmission of it from one host to another. The availability of services must be maintained for users to have access to the information and functions that the service provides. Non-repudiation security principles prove the identities of the sender and recipient when transferring information from one to the other. Authentication practices are implemented when confirming identities, before allowing access to cyber services. When implementing the 5 pillars of cybersecurity, there are both digital and physical strategies that can be used. Over the course of the next few slides, we'll take a look at various strategies that enforce the fundamental ways to prevent cyber attacks. In addition to meeting a list of criteria to ensure the strongest possible password, a password strength can also be characterized by what is known as password entropy. Password entropy is the concept that measures how unpredictable a password is based on the type and combination of characters that are used, like lowercase and capitalized letters, symbols, numbers, etc., and the length of the password. Password entropy is expressed in bits. For example, a password that is known would have 0 bits of entropy. One that would require 1 guess at least half of the time would have 1 bit of entropy. The entropy of a password can be calculated
by multiplying the number of characters in the password by log base 2. So here we have log base 2 s to the L, where s is the size of the pool of the unique possible symbols and L is the password length. Let's calculate the password entropy if the requirements for creating a password were as follows: 6 characters and use letters of the same case. Okay, so in this case, the length, or L, is going to be 6, and the possible symbols will be 26 because it's the alphabet one time, just of the same case. So if we had upper and lower, then this would be twice as much, but because it's just the one case, whether that's lower or upper does not matter, that's going to be 26 possible symbols. S to the L will give us the possible combinations. So 26 to the power of 6 gives us 308,915,776. Finally, we apply log base 2 to that result, and we get 28.2. That is the password entropy for this example. Consider what would happen to the bits of entropy and subsequently the password strength if we were to add more requirements for creating a password. Encryption is the process by which a message or a piece of information is changed to read or display something different to hide the information's true meaning. During the encryption process, plain text, which is the message written in plain language, is turned into what's known as ciphertext, an encrypted text for the purpose of security. An encrypted message can contain many types and combinations of characters that may be similar or completely different than the original message. Encryption is used when confidentiality is absolutely necessary in securing a message. The encoded message will require a key in order to be decrypted. When the key is known and the user wants to know the original message, the encrypted message has to be decrypted. Decryption takes the encrypted message and converts it back to the original plain text. All encryption methods need a key in order to be encrypted and decrypted. When an encryption method is described as a symmetric key encryption, it means that there's one key to both encrypt a message and decrypt a message. The same key is used for both. A disadvantage to symmetric key encryption is that since the same key is used for both encryption and decryption, the key can exist with multiple parties or companies. Trust issues and key security can be a challenge in that situation. An advantage is that if a large amount of data is being encrypted and is not being decrypted by another company, such as when data is encrypted in the hard drive of a computer, using a symmetric key encryption is a fast and efficient way of securely storing data. The main difference between symmetric key encryption methods and public key encryption is that in public key encryption, there are different keys used for encryption and for decryption. To encrypt a message, a public key is made and is known to everyone. A private key is only known to the user decrypting the message and is not accessible by anyone else. Let's look at an example. Bob sends the plain text message, "Hello, Alice." This message is encrypted into a nonsensical but secure ciphertext using Alice's public key. Alice's private key is used to decrypt the ciphertext and output the message, "Hello, Alice," to her device. Think about a few of these scenarios. How does an ATM know which bank account to withdraw money from? How can military groups communicate on the battlefield without the enemy knowing what they're saying? How does a website store and house all of your information? If any of this information was easily accessible by others, what would happen? There are many ways to ensure a safe cyberspace by using physical security strategies. Consider the following points. Understand that any connected devices, like cameras, sensors, and doors, can be considered entry points for an attacker. Biometric authentication, such as facial recognition, finger or eye scans, can improve authenticity in a system. Ensuring servers and data centers are secure from unwanted attackers.